We listen to it and refer to it. And I send everybody the links to typically what we use for this brain dissection, like a link to that, and this chapter 13 PowerPoint D. I do a little bit for because you're going to see at least three of the cranial nerves. Might as well be. We'll get more into the cranial nerves later. So start. Stop laughing. So we kind of were around here. If you remember, I'll look. I didn't get a chance to look as much as I wanted to. I didn't get to do an extra lecture, but I'll try to get one done. It's like a supplementary lecture tomorrow. But this is more function. You're not going to see something as elaborate like this, but you will be able to see the sulci and the gyri once you remove the dura. Got to be careful when you're removing the dura, but it gives you a lot of idea of how things divide. When we get to the dura, you'll see, because ours are very, very similar like that. Dura mater, there's 3 layers, and we'll get to that toward the end. But for instance, areas like this that I'm going to go into in this unit, probably on Wednesday, which I touched on, Broca's and Wernicke's area are really just regions. There's not an identifier. There's not anatomical landmarks per se. And we will have to approximate the central sulcus. Again, the interior portion is in the red, typically in this textbook sequence, and a lot. And the blue are sensory. So I'll be able to describe these better, but it's not very distinctive in the sheet because it doesn't have a really distinctive sulcus. This lateral sulcus separating what's called the temporal lobe, where Wernicke's is, and then you basically have to approximate down here where the occipital lobe is. But you will see at least this line. How deep it is, I can't promise you. And you'll certainly see the cerebellum distinctively. And we're not going to do the cells or anything like this. Is going back to lecture. We're able to, over time, everything is contralateral, which means if my right side of my brain is with my left arm, my left foot, and the other way around. And everybody's familiar. It's not always that way. If I want to stick out my tongue, it's the right side of my brain. So the circuits on the same side. They are not as common. And when I do cranial nerves, we'll identify that. And that's a cranial nerve. This is interesting. We'll get to it then. This is how, for our bodies, they've been able to identify both motor and sensory areas on the lobes and the lobes of the brain, where we actually move these structures. And it kind of gives you a ballpark of how much it is for each. We interact with the world facially, upper extremity, somewhat lower extremity just to get around. But we sense the world in the same way. Okay, lower extremity, upper extremity, facially. And then you see other things are relatively limited. If you get to the abdomen, that's why when you ask the next 10 people when you have a stomach ache, where it hurts, they'll give you 10 different locations. Some will be low, some will be high, it'll be up here. Effectively, it's because you don't have a lot of sensors. You ask somebody where they get a splinter in their hand, oh boy, they'll know right where it is. Maybe you can't see it, but they will know. Right? This should all be making sense to you. Awake. You wanted me to do all this. See your bright smiling eyeballs. You gotta stop staying out of light late at night. Yeah, do they? Sure. Tease somebody. I used to joke that students would run into my daughter on the south side. She and her husband nearly bought a bar on the south side. Go figure. And again, this is more premotor, Broca's, frontal eye fields. That's all. You're going to do a variant of this when we're going to see the internal areas. This is really important. White matter is something that's going to be very visible. This very, very thick piece of white matter, I have students, and generally almost all dissections do this, basically take that sagittal sulcus, the sagittal fissure, right down that sagittal area where where you saw the suture area. And if you go straight down, you open it up with your fingertips, you'll be able to see a white, relatively distinctive structure. That is the corpus callosum. That's the major white matter that connects the right and left sides. We'll go into how it's named. There's three types of fibers. Ones that go right to left. That's principally this. There's also some we get to spinal cord. Not doing that today. You have ones that are called association fibers. They're only on the same side. And ones that are called projection fibers that go up and down. You're going to see a little bit of evidence of all of these in the brain, but this is a relatively distinctive structure. When you cut through it, you're going to see this interior. Not going to look like this. I'll show it to you very soon. We'll get a hemisection. And this is talking about when stroke on the left side affects the right, stroke on the right side. You remember me telling you about it. That was the granddaughter I was with. She was doing really well in soccer, but it's all left foot. She can't use her right barely at all. But she's getting around. It's a joy. An absolute joy. Because we didn't know it was going to happen. So that is a wonderful thing. I don't know how this family is going to do it. They're going to spend 2 years, roughly July 1st, in Bahrain. An island in the Gulf. You guys know where Bahrain is? Persian Gulf, our major naval base, Central Command. Let's say what many of you wear during the summer would be, or are wearing now, would be totally inappropriate. She's going to have to wear long, below the knee. Her hair, is going to have to be, yep. Well, that, you got the idea, everybody, right? Two years. All right. We'll get over to that. Sensory areas, again, it doesn't pay for me to go through all of these because I'm just going to see the sensory part of the brain. Same thing here. I'll discuss this. So this is really the same illustration. So you're not getting, this is more functional than anything else. The same thing with vision. We'll just look at the areas, the lobes. So you should be able to identify temporal, parietal, frontal, occipital, and the basic things they do. When you start getting into balance, that's deep inside, and you're not going to be able to see the detail. Same with smell, but you will be able to see what we call the olfactory bulbs. That's the highest, vertically speaking, of the cranial nerves, called the first cranial nerve or olfactory nerve. That's why smelling salts work, because you're smelling something very stimulating. Typically, we use spirits of ammonia. Something that's very, very distinct. There's a variety of ones. Typically, in the old days, in my office, this was the rule. It was all the offices. My office was one of the first ones in my county where I practiced to get certified for UPMC's HMO, health maintenance. We'd have a padded tongue blade for seizures, and we'd have taped on the wall a little packet of smelling salts in case somebody fainted. And you always had to have that in easy proximity. That was the rule. Signs everywhere, all that. I had this wonderful gal who was she wasn't a science major in college, but she was great. I paid her all summer to get that. She was a great organizer, which I am not. So that's where olfactory comes in, and you're going to see those. They're very distinctive. Animals have a much better sense of smell because they get along. It's very, very primitive. Taste is somewhat primitive, and we'll get to that as well. So again, this is the view you've seen before, and you've seen that before. And you talk about some of these things. I'll comment on this in lecture, certainly on Wednesday. I think this is really important, particularly the anterior association areas and things we call multimodal. That's really memories and tying things to experience. All of these, it's what we are. I'll just introduce it briefly. I love old movies. By my standards, this is not that old. It's one of the best movies ever is 1975, called One Flew Over the Cuckoo's Nest. Did anybody ever see that? It's okay. I can take the hit. My favorite movie is almost 100 years old. Don't start. Very, very famous play about when they did frontal lobotomies. I'll leave it at that. You can find it anywhere. You can YouTube it and watch the commercials, Pluto TV, any one of those apps that are free, just watch our commercials. Go for it. Okay? And we'll talk about that. That's the complex region: intellect, cognition, recall, personality, which I'm sure some of you have. Don't look at me like that. Don't you know what I'm joking? No, my wife doesn't either. She said when she was in class, she goes, you're just going so fast, nobody knows when it's a joke. Indicating to me I tell you, one time she threw a test at me and goes, and in the middle of the class goes, what the hell do you think this is? She still opted to say yes. And limbic, we'll get to it, all that type of stuff. Okay, nothing else exciting here. Lateralization, I just talked about. For instance, I always look in class who's lefty or who's righty. Typically, about 10% of us are left-handed, and that's the whole idea of. And typically, folks are right-handed, left side dominant. And there's a lot of overlap. Your right side and your left side always know. For instance, I am the ultimate left side dominant. Language, math, logic. I'm sitting in touch with your inner nerd from age 5. Okay, pocket protector, the whole thing. Really, chemistry set, that guy. Right, visual, spatial skills. My kids could have beat me in Nintendo when it first came out, when they were 6 and 7. Yeah, I mean, intuition, emotion out of that play. I have zero artistic, as you've seen my drawings, and musical skill. I used to have a good singing. Smoked it out. Done with that. Back to that Wednesday in lecture. Okay? Moving right on. See, we're moving. We're making progress. Trying to be nice. This is the white matter. It's going to predominate. You're going to see it. The gray matter on the sheet, the external cortex areas, relatively limited. Okay, the white matter is very, very distinct. Inevitably, there's more white than gray in most of these areas. And everything is basically signals. And again, these are the 3 types of fibers. White matter because they are myelinated. The commissural means right to left. The principal one you're going to see is that corpus callosum, which means hard body. Corpus is body, callosum is hard. The association areas, basically, we are constantly shuttling signals back and forth. Oh, what did you see that way? What did you look like? What do you want to respond to it? It's like you're taking a test. Okay? And then projection fibers, message up, message down. Okay, mark letter A. Okay, erase letter A, mark letter B. That type of stuff. So all of that is part of it. So it gives you a nice thing. You'll be able to see some of them. I'll show you where they cross over in just a GIF. And so the other ones, this one, you can almost peel off the large cerebral lobes, and you see it's almost like a feather edge. It's a combination of these 2 structures, the internal capsule and the corona radiata. Again, corona, like coronavirus, means crown. And if you study the coronaviruses, the external coat, basically the proteins on the external on that enveloped virus had an appearance of a crown. So this does as well. It's like, and you'll see the fibers, and I've had a few good specimens where you can see it, and radiating. These are projection fibers. Basically what you'll see, the thalamus, which is relatively large for a small structure. For the structures as we get, that's the sort of the hallmark structure of the next part of the brain called the diencephalon. As we work our way down, that's the part that edits, sorts, relays. Okay, you're visual, you're going to the occipital. You're hearing and balance, you're going over to the temporal. Wait a minute, your general sensation. And not only here, but what part of here. That's kind of what it does. And there's a lot of named areas that you don't have to know. This is, you could make this cut if you want. Because we have, you could, you could slice these brains and take a look. But I mean, you're going to see there's, comparatively speaking, not a lot of gray, but a lot of white, okay, matter that's here. The cerebellum, you can see, is distinctly different with the way the sulci and gyri run. But here's that corpus callosum. It's so distinct, and you're just going to slice right down. Don't do that first. I'm going to have you look, I'll explain to you how to do it the way I would prefer. So here you can see these fibers that crisscross. Fancy name, but you're going to have to remember, called decussation. I know it's crisscrossing or crossing over, but they're decussating. Go with it. Okay, and this area is where pons, and the pons is located, and it continues on through the pyramids. And they're little mounds, very hard to see on the sheep brainstem because it's so darn small. You're talking about the brainstem is maybe an inch, as opposed to, maybe ours is 3 times the size, let's say. So here they are crossing over. These are the pyramidal mounds. This fairly large area is the pons, where most of the crossing occurs. Here, as you work your way up, this will be the midbrain, and now you can see those big lateral ventricles. You might remember we discussing those hollow chambers that are filled with spinal fluid, and you'll see some evidence of where the spinal fluid is produced. And again, these are the thalamic areas we're going to come to in a second, and that would be like the corona radiata, part of it. So you see better from this view. See, this kind of looks like a shell, like you would a seashell. That's that corona radiata portion of it. The thalamus would be in here, and then here's the rest. And you can see the orientation. Our frontal lobe is much more substantial. The sheep's hard to tell, not as distinctive. You're going to see this opening, this fissure between the occipital lobe back here and the cerebellum. You're going to see this remarkable structure on the cerebellum called the arbor vitae. And arbor means tree and vitae means life. Like if you're in academia, okay, we don't submit a resume, even though it's a resume. It's called the CV, or curriculum vitae, which means your life's work. Okay. So if I'm applying for another position here, they'll say, please submit your vitae. So that's where resumes kind of go from most recent, going back toward what your schooling was. Curriculum vitae kind of go the opposite way. They go from your schooling and then what you do. These days, if you ask for either one, it'll be submitted. There's a rumor some of you are going to have to start looking for jobs after college. So you will see these. I'll show you where these are. You don't see them that easily in this extension. They're called the basal nuclei, used to be the ganglia. I explained to you, nuclei are these clusters of gray matter. These play a pivotal role. And I'll get back to the track or the passageway. And that'll be more of a lecture point. Because they look like stripes, so it's called the corpus striatum. You don't have to know all the different areas of it, but I'll show it to you. So, oops. So as you open up the brain, could you stop doing that? I didn't touch anything. As you open up the brain, you won't see this, but you'll see evidence inside the little cleft in that large lateral ventricle where you see some of that gray matter. That's what that is. And now you begin to see behind it. Now we're getting lower. This is the thalamus, diencephalon, and that's the one large structure. The others are very tiny in the sheep. Now this is medulla, the pons. You can see the fibers go transversely, and this is the midbrain area. And all of these things: muscle movement, cognition, this is where Parkinson's and Huntington's disease. You genetics people, did you do Huntington's Chorea? Yes. You're looking at me with blank stares. I'm not talking about a pedigree. Do you know what Huntington's disease is? Good. How is it passed? Is it sex-linked, recessive? No. Say it again. Autosomal dominant. Really big disease, autosomal dominant. That was what you don't have to get neurofibromatosis von Recklinghausen's. The elephant. Are you guys familiar with that whole story? My first wife, her family had one. And none of them looked or passed that. That's one of the reasons, maybe the major reason why we didn't choose to have children biologically. Because mother who died recently had it, and her presentation was called bone and skin. So there's 5 layers, 5 levels. Type 1, bone and skin. The skin is called cafe au lait spots. And they show up much more visibly in larger numbers at roughly puberty. And they are, it's almost like, fair to dark skin. Cafe au lait is bone. So it's a very distinctive spot that you can see. There's a lot of pigmented lesions. And these neurofibromas are nerve and fibrous tissue sort of intertwined and making you all. She had that some movement in her face. Some have come back over the years. So she's got these little bumps, and I sort of help. And probably has helped with her health. Unfortunately. She's doing pretty good today with her. So her dad had bone problems with a fracture that didn't heal, and her brother had a scoliosis and had an operation and a body cast clips on. So these are real. And really the interesting thing, genetically speaking, you pass on traits, 50-50 composition for most people. Okay, you don't. You could both be in stage 1, with one partner could be in stage 1, and you could have that. 10% of people get optic nerve adenomas, tumors in the optic area. So the adopted children, there's no saying like, pay your money and take your chances, eat this. To adopt 3 children. My wife, when she went to the ophthalmologist one time, was really excited. I want to take pictures of your eye. She had a freckle in her eye, in the pigmented portion of a leash nodule. Very common finding in neurofibromatosis. Took my daughter for eye check. I forget what I brought her over to Children's Hospital. No children. Someone's looking in her eyes and goes, "Whoa! It's a leash nodule." Yeah, MRI, no optic nerve glioma, CT, and all that. It's not a skin gum. Imagine, he thought that to avoid it, he might have read more away. Those sometimes destinies like I have all sorts of these interesting topics. Whereas my wife frequently says to me, "Your family's crazy." And I said, "Have you noticed your family?" Everybody else's family is nuts, believe me. It's everywhere. So, and Huntington's disease really is a very good genetic study because we know the marker and all of those things. And again, this is when Parkinson's is a generic term for things that affect the pathways and neurotransmitters. I'll do that in lecture. So kind of this is what if you did this slice here around those ventricles, you're going to start to use it, not where the thalamus is, which is fairly easy to find. You begin to see these darker areas. And again, they looked striped, so they called it the striped body or corpus striatum. Okay, and now the diencephalon, you'll see this. Thank you. This is called the hemisection, mid-sagittal hemisection, right down that sagittal, okay, fissure, whatever they call it, sulcus fissure, who cares? Once you will see this, an egg-like structure, that's the thalamus. before you cut in there, if you sort of peer, if you separate the occipital lobe from the cerebellum while they're both intact, you will see this protruding. It looks like a little pine cone. They named it the pineal or pineal gland. It's part of endocrine. We still don't know what it does, other than make melatonin. So it obviously has a role to do with sleep. This is almost, you almost cannot see this on the sheep. It's so small. This is the hypothalamus. It's the link between your basically your nervous system and your endocrine system, because the heart of your endocrine system is right there. Okay, that's the pituitary gland. And so the pituitary gland, you're going to see an endocrine, a little piece that we might see the remnant of in this, called the infundibulum. It's a little tongue-like projection of actual brain, forms the posterior portion of the pituitary gland, and the glandular portion is the anterior. So it's the in-between. And just ahead of it, this is the optic chiasm. If you're going to find, and I can't say anything really about them now until the last test taker has taken said test. It's not listening. It's okay. I can't say anything until you take the test. It's all right. I mean, is that a Yankees?
No, I mean, it says New York.
Oh, okay. Yeah, I mean, please, I had 2 very bad days. But you will see, I mean, effectively, these are really important areas. This is the optic chiasm. Notice the proximity, for now, between the optic chiasm and the pituitary gland. You're going to see where that is. You're going to see the remnant of the optic nerve. That's the next cranial nerve. That goes directly into the thalamus, and then basically pre-processes visual impulses, and by way of something called the optic radiation, goes back to the occipital lobe for regular processing. Then once the image is identified, finalized, it gets shuttled forward, okay, and then eventually your brain interprets, oh, that was my dog, that was my cat. That wasn't my cat. Why is it in the house? There's a stranger among us. So as you're above here, in that, you're going to see this opening here is where the lateral ventricles are, and it's filled with fluid. You'll be able to probe in there once you slice down and see this view. Surrounding this, okay, is the third ventricle. You'll be able to identify that. You'll be able to identify these. You're going to see little blackened stuff. Blood vessels, and almost all veins, retain their blood. Arteries typically do not. So what you'll see when you see little nests of kind of dark looking yucky stuff, it's probably a vein. And that would be, and we find these choroid plexes, that's the plural, in the ventricles. You should see this one. You can almost run the back of your blade or a probe around it to sort of feel this third ventricle. There's an opening that's hard to find, but when you get below it, you'll easily be able to see it. This area, okay, as you can see, as we begin to go behind that, it's called the cerebral aqueduct. And it separates here. This is the midbrain, relatively small, relatively untouched from development. It's expanded. The midbrain has an anterior portion where neurotransmitters. These are 2 big bodies. And again, before you slice it vertically, look behind there, and just below the pineal gland, you'll see 2 bumps on either side, and then another set of bumps below them. They're called the corpora quadrigemini. It just means 4 bodies. Actually, there are 4 nuclei, and they're responsible for what we call head and neck reflexes. They're very important and protective. So if I do this, and you see somebody turned around. When you hear something, you instinctively turn your head. If a light comes on, I'm doing it for example. Okay, and the very fact that somebody moved distinctively just helps make the point. Well, I mean, We drove 5 hours with the Beltway and traffic yesterday up from DC. We didn't get home until after 8 o'clock at night. Blah! And I mean, sirens, what do? You hear a siren, you start looking at my rearview mirror or anything like that. We saw on 70 going down on Friday, a car, completely engulfed in flames. As we went by, my wife was driving. I fortunately didn't see anybody in there. So hopefully whoever was in there got out. Car, shell, and just a massive fire going inside of it. Wow. I'd never seen anything. And I've only been driving for, 57 years, something like that. So you see this aqueduct, and it opens up into yet another ventricle called the fourth ventricle. Here's another choroid plexus, and here is what you must identify. That white, this is and you notice the cerebellum has more synapses. It's responsible for processing every movement that you make. Yet one of these that's unique about it, we call it ipsilateral, meaning when I move my arm, it's kind of recording, you move this muscle, all on the same side. And it sort of puts it, it's like a muscle memory, if you want to think of it that way. And so all of it's got all these sensors. So it's things that when you're walking, I mean, you and I are walking, you can feel it's under your feet, usually on a careful surface. Okay? You can do this all, you can close your eyes, your feet are telling you, and you're processing the sensory information. So the cerebellum is all about that. It's a very, very famous sign that you're going into a clinical field, you'll hear about it. It's called Romberg's sign. Positive called the 2 out of 3 law. It means cerebellum, what we call proprioceptors. Those are the little sensors we have all over your body. Now, if you close your eyes now, you would know where everything is. While you close your eyes, you know where your right hand was, your left hand was. You know, again, hold it if you're holding the writing instrument. They were facing forward. You don't have to go standing up and sitting down, wouldn't you? I hope. Unless you're out for a really long hike right? Of course. You know what I mean? Your cerebellum, those are called proprioceptors. Every time you move, you know if your eyes will move to the left or moving to the right. If you didn't, that's one of the ways we diagnose these. So the proprioceptors are tiny sensors where the body parts are at any given time. They are all coordinated with our cerebellum, and a lot of times if we can use our eyes. So in order to maintain your balance, you need 2 or 3 of them. So let's assume that my feet, I couldn't feel my feet like diabetics. People diabetic, you watch them walk. They're walking to make sure their head down, they want to make sure they put their feet. So if you're diabetic, say close your eyes and try to walk, they couldn't. You wouldn't keep your balance. What else does that? Hopefully you've never been involved in a roadside event where maybe a local police officer has asked you to walk a straight line with your eyes closed, or do this with your eyes closed. Few of you. Totally agree. That's okay. Yeah, okay. I won't get into as much. Okay, that's Romberg's. That's the field of sobriety. Because alcohol is the cerebellum out of play, and if you take your eyes out of play, now you just have proprioceptors. I had a lot of diabetic patients who decided to drug abuse, and then if it was mistakenly arrested. Like, I was up there, well, you treated this so-and-so for a drug case, of course not. Uh-oh. Because, because they see some guy doing this, and maybe because of his eyes, his glasses, the next thing you know, the police are suspicious. Because a lot of times diabetics, when their pubic are out of control, their breath has a very acid odor. It smells like it. having quite a few. And so all of this is communicated by this network. There's a lot of white matter. The arrangement looked like a tree. So they called it, the old anatomists called it the tree of life. Okay? And so that's a very, very common term that's associated with it. One goes up here and one goes down here. And those are called peduncles. A peduncle is a pillar. So you have, these are called cerebellar peduncles. You're also, if you go backwards, you have cerebral, you can see cerebral peduncles coming from the thalamus. And really they're just bits of white matter that are, being able to, it's as though they were holding up the head, the brain, and cerebral lobes, but they're not. So that's a very famous name, Tree of Life, Arbor Vitae. I'll tell the story, you don't want to hear it. Is there a famous Tree of Life in Pittsburgh? Now where is that? Go ahead. Go ahead. Now a dozen people died. I believe that was before COVID. I think it was October of 18. Either October of 18 or October. I'm concerned on that. Maybe 7. Is that right? The British just put it this way. In the list of people who died, there's 2 fellows who, okay, for context, my first wife and I got married, I was in July 1970. It was amazing. Still going. And if you look at those, and there were 2 young boys there at the time who you see nowadays we say, well, they might be on the spectrum, do some type of parlance like that. Who obviously had time for this, with handing out prayer shawls and prayer books. We never missed it. Their sister with the Steelers forever. Also, I had three the Jewish community contract. It's less of a story than it used to be. They actually 3 different congregations. It's like 1,000 people. That's my knowledge. So it was normal. So they had a sanctuary, they had a chapel where we went. Downstairs, after the kids were there. So they had 3 different congregations. This is named Dr. Jerry Rubin. A very well-known picture, bow tie, little guy, still down the street. Fortunately, he died. That's just, you see, was heard the shots, being who he was. And we were not that. We were in high school in New Jersey. And we managed this because my late brother-in-law, my late ex-brother. This one, that's what I remember. And he was a lovely guy, very well loved in the community. One of the early doctors who embraced treating AIDS patients. And what did he do? Like most of us, you hear gunshots, I'm hiding, right? He's running because he's looking. Ran right into this assassin. So I always tell that story when we do this. I hope you're not troubled by it, but I mean, that generates a memory. And we developed a scholarship fund at our old high school reunion, stuff like that. Just so sad. Because he was in our group. He went to University of Pennsylvania undergrad, University of Pennsylvania Med School, an internist. Moving on, same illustration. You'll see this, this looks more like this in real life, but the sheep is so much smaller. So the thalamus, you'll see them, 2 little eggs. And again, this is all, in med school anatomy, graduate anatomy, you have to learn all these things. What comes in lateral geniculates, medial geniculates, and oh my goodness, all that type of stuff. Sorting, editing, relaying, etc. Mediate sensation. There's some cognition as well. If you want to think of subconscious, maybe here. Okay? Regulating emotion, visceral function, impulses from the cerebellum and the basal nuclei. So it's really assist. As long as it's intact, it's just like anything else. It would be significantly missed if it was unavailable. And then, the mammillary bodies are part of something called the limbic system. This is your emotional center. You do not see them all on the sheet. Here's that infundibulum. So you don't get this definition. It's there. And we'll go past the hypothalamus. We'll spend a lot of time on in endocrine. We do all the endocrine basically because it's really it's so limited anatomy. It's a physiological system. All those types of things that are there. And the epithalamus, pineal gland, melatonin, best we could say about it. And these are the other ones that you will look and see. These are called superior and inferior colliculi. Anterior to them and right in front of the midbrain, those are the cerebral peduncles. They're the big white matter tracts. They're really bringing signals down from the brain and back up to the brain from other areas, if you're wondering. Here's what it looks like from behind pineal gland. It won't be this distinctive, but I'll be able to show it to you. There's one of those choroid plexes. These are all cranial nerves. So I'm not going to go crazy with them. You should be able to at least identify the midbrain pons and the medulla. And we don't go any, and maybe the first three, sometimes you'll get lucky and see, and the first three, and certainly the fifth cranial nerve. This is the view that we will look at. This is a very, very famous ventral view. You will see this on the sheet. Underlying frontal lobes, those are the olfactory nerves and the olfactory ganglia. They sit right on top of one of the structures that I had you identify for the exam. They're there. That's the optic chiasm. You will see that. The mammillary bodies are these two, and they're named because they look like little breast-like structures. In the sheep, they're so small, it looks like one little mound. That's there. This is probably where the infundibulum, that little mini stalk, where the pituitaries, you're going to see the pituitary. And so the optics, first cranial nerve, second cranial nerve, they're both sensory. Third cranial nerve here, which you'll see, or at least a portion of it, that's they call the oculomotor. That's the one where you're controlling eye movements, up, down, side to side, that kind of thing. So think of what happens, and the way to frame this, when they used to do concussion testing on a sideline, what did they have you do? Okay, well, first make sure you're awake. They would use smelling salts. Then it would be visual, the type of thing where how many fingers am I holding up? Then the next step would be follow my finger. So up, down, side to side, and even bringing your finger in because your pupils do something. And I'm not going to go into it today because it's better to talk about it when you're more familiar with the anatomy. And I want to make this the brain part rather than the others. And then you work your way down. There's a small nerve that comes around here. I see rarely, called the trochlear. It also helps to move your eyeballs, as does this, the abducens. And by this time on the sheep, they're little threads. Very, very difficult to identify. The one here, it'll end up coming off when you remove the dura mater. I have to get to the meninges to keep going. We still got another half an hour easy to go with this. Sorry to be so wordy. But that's the trigeminal nerve. Oh, get used to hearing about that. So where my first wife had neurofibromatosis, my wife today suffers with something called trigeminal neuralgia, and you wouldn't wish it on your worst enemy. So you see where it is, and when we get to that part of the cranial nerves, I'll identify it. Okay. You'll begin, and you don't see a whole lot after this. The colliculi, it's probably in the sheep. It's not this substantia nigra and the red nucleus. Not as distinctive. The reticular formation is about keeping you awake. We'll do that in lecture. This is what the midbrain looks like. So these structures in us, these are where neurotransmitters, those chemicals that cause our nerves to communicate. This one from substantia nigra, and I'll get back to it, plays a really important role in and then the pons, and I'll show up. Again, you're not seeing much. These are the big trigeminal nerves. That's the largest by diameter of all the cranial nerves. This is where the fibers of we call the pyramids are crossing over, right to left. That's all instructions from my brain to move the rest of my body. You saw that illustration. That illustration, the same thing. The medulla. These are, and it's not distinctive on the sheep. They call these little mounds pyramids because they've had a pyramidal shape. This is larger in our brain. And the cerebellum again. That's that arbor vitae. These are the cerebellar peduncles. They actually come across, up, and down. So it's really involved in sorting, editing as well, collecting information, but from the same side. Here's their illustration. That's the fourth ventricle. You'll be able to identify that. They used to think there was a little guy here. Let's see it. Because they thought, I mean, it was like some little mini person in there. They're controlling things. Crazy don't be seen. Don't do that. Where's B? I lost B. Oh my God. There's very little in B, so don't worry about it. You can lose it. Hello, B. Oh, we did B. That was B. Why didn't you tell me? You're not helpful. You're a dodo, Lou. C. Okay. You won't see this. I'll get into it. This is about emotion. The limbic system is so important. It's very, it's gray matter and some of the structures that surround that area. I'll show you the other. This is pretty good. You don't see any of these. Think of when you open up, and it opens like a book on the interior pages, is where some of this. For instance, this is one of the lobes, the internal lobes or medial lobes of the cerebrum. It's called, because it's C-shaped, it's called the cingulate gyrus. In here, on the medial lobe of one of the temporal, this is the hippocampus. This bulb-like structure is the amygdala body. Here you can see the olfactory nerve plays a role. All of these structures, which you don't get a good view in the sheep, are so extraordinarily important. It's where our emotions are basically generated. We see things through our emotions. In some people, they predominate. Anger management issues, typically from here, the amygdala. When you hear about people, particularly, we see deterioration here in the hippocampus. We particularly see it in Alzheimer's. Because what do they lose? Short-term memory first. My mom succumbed after 3 years struggle with Alzheimer's, and she was extraordinarily, as I've told you, extraordinarily with it and cogent. Up until maybe 87, 88 years old. And then, boy, does it go. And smell. Smell triggers memories. More so than almost any other sense. Smell, because it's plugged in. Think of you when you smell something good. Wow. When you smell something, it's like, you're repulsed. That kind of thing. So, I mean, we see it, emotional responses associated with it, hippocampus, amygdaloid body. Won't get into any of that other stuff. This just keeps you awake if you can't see that in the sheep. That's why turning the light on, yelling, think of my children trying to get up to go to school. Now they all get up ridiculously early. Go figure. All right, everything else here. This is all stuff we do another time. Not doing it. You're almost done. Me blabbing. The amnesias, we'll look at that. We'll look a little bit at electroencephalograph. We could do an electroencephalograph if you're interested. Not a whole one, but I could show you some brain waves for those who are thinking. Maybe we do that next time. That might be fun. Just for fun. We don't have the whole get up, just a couple of electric. And I'll go into the whole thing about that. So I don't know anything about it, but it's just kind of like fun to do. See that there's actually, even when some of you are sleeping, and we'll talk about seizure disorders and how they are today. I'm getting to the important part, not the REM or any of that stuff. Ta-da, ta-da. Meninges, because we have one with meninges. Meninges or meninges, however you want to pronounce them, they are the 3 layers that cover our brain. The ones you're looking at here, where these thicknesses are, you have a feel them, are the dura. Dura means durable. Matter means matter, material. So dura means strong. Now, I used to have a piece of dura when I had 20 years ago, when I had access to a human nervous system. You don't have to play tug of war. You know, that's how strong. You have to cut it sharp. This is the way you have to cut this sharp. It doesn't tear very easily. Okay? And beneath it, the layer that's adherent, you can't really identify to the brain itself, is called pia, the soft, the delicate matter. The arachnoid is interesting. That's where the cerebrospinal fluid is, in what's called the subarachnoid space. So you really won't see it here. It gets its name because it's got like little gossamer strands, but it's right there. And it's arachnoid, using that particular indicator for it. And so in the brain, not in the spinal cord, you have a separation in the dura. There's one that adheres to the skull bones and has one, and it separates, and these natural separations, okay, as you will come when we do blood vessels, okay, become sinuses. Sinus isn't just like in your nose. A sinus, there's a lot of different sinuses. It's generally a space. Here, this is a little pocket that collects the blood that's coming out of your brain and mixes it with the cerebrospinal fluid. These are like little siphons or overflow valves. The cerebrospinal fluid, basically, as it's on the, it's created from the bloodstream. It's released. It isn't just in the interior area. There's little outflows in the 4th ventricle that help it go outside. Also, one at the bottom of the spinal cord. And every day you make about a pint, and every day you absorb about a pint. Okay, and this is where they absorb. So these what they used to call arachnoid villi. Okay, now they have a ride. Now they call them arachnoid granulation. To me, best thing like little overflow valve would be described. So here, and you can see where there's blood vessels. So, but really where the bleed, we get bleeds that are subdural in this area because there's blood vessels, and we get bleeds here that are subarachnoid. And the trouble is the pressure is intense. You have to release them. So, I mean, this is where, in one of those, in a capable emergency room, they might have to drill a hole in the brain, right, in the skull right away to release that now. That's something you watch for with concussions. Okay? The sign in concussion, and why, if you didn't know concussion protocol, when we suspect that, and this is typically like little kids in sports, you have to wake them like every 15 minutes for X-Men. See if they're, I just got to sleep and they're not happy with that. And the same thing, that's what concussion protocol. The watch sign to watch out for, everybody, if you decide to have a family or you're around little kids, projectile vomiting. They start to, all of a sudden they get, I got to vomit, and it goes, you get them in the emergency room now. If they had any type of head trauma, please. And do not give them anything stronger than Tylenol. You don't want to suppress that. Adults go, my head's killing me, I need something strong. Suck it up. So this is the subarachnoid space. You can see the strands. The pia, can't even see it. So that they're just commenting on that. These thickenings are called in us, and they have them here with the sheep, falx. Cerebri, there's a falx, you'll see in the cerebellum, and there's this horizontal fold. That's the one I kind of want you to separate before you slice down. So I want you to identify whatever you can externally before you look internally. When we do blood vessels, we'll talk about these sinuses, et cetera, that are there. And this is just the rest of the same illustration, same. We'll talk about that. Let's talk about the cerebrospinal fluid. And this just shows you how it flows. There, and that's what happens when the fluid doesn't get unshunted, and we'll talk about the blood-brain barrier, which is important. And then we'll discuss the difference between concussion and contusion, which, by the way, are different for the spinal cord. Contusion is bad, is worse in the brain, it's better in the spinal cord. Spinal concussions are worse. Think Ryan Shazier, Steeler, whose career was ended. So we have a lot of things, and we'll talk about that, and TIAs and Alzheimer's. And you can see the difference, how brain areas just stop functioning. Shut down. Parkinson's, Huntington's, etc., etc. Good. Nearly done, everybody. Take a deep breath. I just have to show you that some of that cranial nerve stuff. Give me 3 or 4 of those, and you're good to go. Then I'll show you how to do the dissection. I'll take a drink in the meantime. So you have these cranial nerves. We'll do the presentation again. You have 12. The task of every anatomy student is to figure out a way to memorize these 12 nerves. And aren't you lucky? All those holes in the brain that a lot of you happen to know, you're going to know which hole the nerve goes through. Thank me. It's all part of the service, dear. Well, in fact, we were making fun of you, but you were out of it for a while. Do you work? I mean, it looks like you're exhausted. I'm telling you, you got to stop staying up late. I try to get my beauty sleep. It just doesn't work. It's okay. I'm still the winner. My wife is gorgeous. Thank goodness for that visual impairment. Why would she be with me? Olfactory and optic. First two, purely sensory. We're going to get to what's meant by parasympathetic. Oculomotor, third, eyes. You probably won't see the trochlear, but that helps eyes move. The abducens, unlikely to see. And that's all 3, 4, and 6, all exit the same way, all involved in what we call extraocular eye movements. The trigeminal is mixed. Most nerves are mixed. This is where this particular chart, which is good, has lack. Any motor nerve that's that proprioceptors. You know if your eyes are in and out, okay? You know that. It says motor function, sensory, it says no. You certainly know if your eyes are up, down, side by side. Those are proprioceptors. So if they're talking about major sensation, I'll buy that. But these proprioceptors are just so important to us. So the other nerve that they used to think was for hearing. But we know now that you adapt. It's like loud noise, that noise you hear in the background. You'll adapt to it. If you go to a concert and it's very loud, you go to a bar or a club that's very loud, you begin to, it's almost like a protective mechanism. And it involves the hearing apparatus, the tension being adjusted. There's limitations, and we'll get to that as well. And so olfactory, you'll see, and we'll go over all of this. The optic, there's the chiasm. We'll look and see that it's not all crisscross. Some is on the same side. These are the extraocular muscles. I will go over how all of those work when we do those, how double vision is one of these imbalances. Here's the famous trigeminal. Very, very complicated. It's got 3 divisions. We use Roman numerals ordinarily. For my test purposes, you can use regular numbers. You can put 5 for the 5th. You don't have to use the Roman numeral. But we call them V1, V2, and V3 because we used to use the Roman numeral. And you have a branch sensation here, sensation here, sensation here. My wife has this. And we'll read about it and go into it. It is not fun. And again, more extraorbital. We'll get to all these things, etc. So you had enough listening to me. Even I had enough listening to me. And I'll show you the prep thing so we can look at it. So I sent you this. If there's any one of these, this used to be from a different Don't allow. Scalpel, scissors, probes, we have all those ready. This is one with Dura. So you can see it there. So it has, and this is exactly what you'll be looking at. When you see the darkened areas, these little blood vessels. So here, tough outer covering called Dura. You can still see some of the structures before you remove it. Underneath, you're going to see the pituitary and the optic chiasm. You're going to see a lot of dark stuff. Pituitary is a gland. Endocrine glands go directly into the bloodstream. They're surrounded by like a nest, a large nest of blood vessels, like a sponge. As they spit out chemicals, they get sucked up. And they get delivered in the bloodstream rapidly. The dark areas, the blood in there is almost always venous blood. Again, arteries, veins are wider. Veins retain blood a little bit better. When we do the sheep heart, you're going to see veins flatten out. We do a cow heart, right? Veins flatten out. Arteries, because of increased elasticity and connective tissue, hold their shape. But when we're looking here at smaller blood vessels, that's what sometimes you'll see. So I thought you might be interested in that. And so this is the volar or underbelly. Now this is where you're looking at dura mater under here, and you're going to start to see, here's the brain stem, that pituitary gland. The optic chiasm is here. Here are the olfactory bulbs. Again, rather in animals, much more substantial. I have a poodle. He's got a nose. He could have his nose on the end of the tape. So anyway, I don't care, but when you remove it, it's very hard not to remove a lot of stuff. Try to be as cautious as you can. This is probably the area right around here. Those are probably the trigeminal ganglia that are there. The nerve is, when it comes out, the ganglia are very comparatively large. Again, they're showing it to you again, pituitary optic chiasm. So they removed some of it and allowed that. For instance, that would probably be trigeminal. That would be probably trigeminal. So now they've got it removed. The trigeminal is all the way down here. This is the oculomotor nerve. So these are the three that you'll definitely see. Olfactory, optic chiasm, what's left of them. Whatever was left from the pituitary, this would be like the infundibulum, the little stalk, mammillary body. You only see one. Oculomotor nerve is pretty good size because moving your eyes all around. And then after that, you're really, the next one down is here. That tiny one, the trochlear, you rarely see. It's the only one that starts from the back. See that? So you use your own. I'll leave this up on the screen. And this is what I mean. Once you're able to look, before you cut, this is where you want to separate back here. Pull the cerebellum down so you can look from behind. So cerebellum loosely attached, it's transverse fissure. Here you can see it here, a transverse fissure. They removed it. This is, now you get an idea, frontal lobe. You're approximating the parietal lobe. Maybe the central sulcus is here. Way down here is that sort of transverse fissure or here's the transverse fissure, here's the lateral sulcus. Here's the cerebellum. This is what I mean. If you pull it down, you're going to see the colliculi, or side head and neck reflexes, and this. Deep inside here, you'll see that pine cone shape pineal body. And now this is the hemisection. When you slice it all the way through, that little cleft, this is all part of the corpus callosum. That opening is the lateral ventricle. This is the third ventricle beneath it. This is the thalamus. Okay, it's here. The optic chiasm is over here on this side. And it doesn't take long. And now you're starting, you can see the arbor vitae and the cerebellum, and you can actually see the indentation here for that cerebral aqueduct. So this will be midbrain. Those will be the colliculi in the back. You're lucky you can see the pineal gland, like over here. Cursor is, etc. And now this is fourth ventricle. And eventually that fourth ventricle becomes something called the central canal, which goes all the way down the spinal cord. So it's got a very distinctive circulatory system. And here they're showing you the ventricles. As I said, lateral, third, fourth down here, neogland. You should see all of that stuff. Opening it up, same deal here, arbor vitae. And they put pins, that's fine. So those are all structures you should hopefully be able to identify. So it's actually pretty good showing the gray and the white. And you see when you open it up, you'll be surprised. But at the end of the day, they do a little labeling thing. So I think it's a good little one. So you should refer to it. You can come up here and use the cursor if you want. You want to get started and get this dissecting so you can get out of here? Yeah, sure, why not? For this, you will need gloves. Let me truncate this.